This meeting is being recorded.
Hello everyone. Today I would like to introduce the electron probe microanalysis EPMA, which is prepared by Sami Al-Shamri and Ibrahim Luqman and Jihad Al-Isa. Today I would like to introduce our topic, which is electron probe microanalysis. EPMA is a non-restrictive analytical technique widely used for determining the local composition of solid sample, which is the technique is based on the measurement of characteristic X-ray intensities emitted by the elements present in the sample when the latter is bombarded with the focused electron beam. The transformation from the measured K ratio to concentration is performed by means of relativity sample analytical algorithm, which assume that the sample region from which X-ray change or image has the homogeneous composition. For Ka electron beams, the region is typically about 1 micrometer, depending on the density of the material and the analytical condition. There are physical principles. When the electron beam KV energy range and being on the sample, there are 3 types of interaction may occur, which when the first one, elastic scattering, the initial and the final state of the atom are the same normally. The ground state, these interaction change in the direction of movement of the electron. The second one, elastic collisions. The atom is brought in the excited state by the following process: excitation of the electron in the condition of the valence band. The second one, which is plasmon excitation. The third one, inner shell ionization. The third one, emissions of pre-emission, take place when the electron is located in the electrostatic field of that target atom, has almost no effect on the electron trajectories, but it's the source of the country's background and X-ray spectrum.
Okay, in the electron probe microanalyzer EPMA instrumentation, basic components in the EPMA instrumentation, you have the electron gun and the electromagnetic lens, or you can say the column, and X-ray characteristics EDS and WDS, detectors SE and BSE. Electron gun, 3 electrons are created in the electron gun by heating a tungsten filament cathode. This is the types of the electron gun. You can see the shape of the design, the electron gun to formation more of the electrons, commonly used the lithium hexaborate in the electron gun. Electromagnetic lenses, a series of electromagnetic lenses located in the column of the instrument, used to condense and focus the electron beam emanating from the source. For example, we have the condenser lens, objective lens aperture, and aperture angle control lens, and hybrid lens. X-ray characteristics, energy dispersive spectrometer and wavelength dispersive spectrometer. EDS and WDS use the characteristics X-ray generated from a sample, bombarded with to identify the elemental constituents compression of the sample. This is the EDS and this is the WDS in the EPMA. The EDS and the WDS have many advantages and have many limitations. For example, in the EDS we have the limitation of the liquid nitrogen, but in the WDS we don't have. But the WDS we have the mechanical movement, but the EDS we don't have the mechanical movement. And this is the spectra of the EDS and the WDS. You can see the WDS peak is very good than the EDS. Detectors, secondary electron and backscattered electron. A variety of detectors arranged around the sample chamber that is used to collect the X-ray and electron emitted from the sample. This is the secondary electrons used for the energy lower electron detector, the lower energy electrons, and this is the backscattered electrons used for the detectors higher energy electrons.
For the example of application, EPMA capabilities include point analysis, line profiles, and X-ray mapping, both qualitative and quantitative, as well as the determination of the composition and thickness of thin films and multilayers. EPMA can be used in the earth and environmental science, also in the material science and physical metallurgy, and in the medical and industrial. For the characterization of the double stainless steel are a family of steel grades. that the use of DSS at high temperature requires knowledge of the phase of transformation that they undergo after heat treatment. EPMA is a valuable tool for the characterization of DSS. Figure 3 and its PSE image showing the microstructure of the DSS sample after heat treatment. The following phases can be observed: ferrite, alpha, and austenite gamma, and secondary austenite gamma 2, and the S and the C phases. Figure 4 and its X-ray spectra around the position of unmeasured on an austenated grain gamma. And the second application is analysis of chemical segregation in ferric steel. The application require knowledge of the deformation mechanism of the steel and the effect of microstructure and microsegregation on their behavior during deformation. A convenient method to analyze microsegregation is by means of X-ray mapping. Depending on the area, X-ray mapping can be obtained. The figure 4 and X-ray spectra around the position of unmeasured on an austenatic grain gamma, and the color map in the right-hand side showing the density of position.
Recorded.
EPMA is not able to detect the lightest elements H and HE and Ly. Some elements generate X-rays with overlapping peak position that must be separated. EPMA analysis are reported as oxides of elements, not as cations. And EPMA analysis also cannot distinguish between the different valence states of Fe. So the ferric-ferrous ratio cannot be determined and must be evaluated by other techniques.
Okay, in the final slides, we have the 5 questions and with the answers. The first question: how are samples analyzed in EPMA?
Actually, the window creative from beryllium, which is the sample is analyzed, all the sample or the kind of the sample.
What is the difference between SEM instrument and EPMA instrument?
Okay, the difference between the EPMA and the CEMA instrument, in the EPMA we have the WDS part, but in the CEM you don't have the WDS part.
What is the role of vacuum in the EPMA?
The role of a vacuum in the EPM, because of strong attraction between the electrons and the samples or the specimen, many of the gas particles should be absent in the vacuum.
And how EPMA can use in medical and industrial application?
EPMA can be used as scattering chamber to determine physical quantities related to the production of X-ray, which are needed in medical and industrial application.
In characterization of stainless steel, what nitrogen can do in DSS properties?
Nitrogen plays an important role on the properties of DSS, as it can partially replace an I, which is of economic interest.
Okay, thank you for your attention, Doctor.